Hey everyone, in this video we are going to see what is mean by Internet of Things. So we will see the basic applications of Internet of Things, and before that we will be seeing first what is mean by Internet of Things and what are all the key features about the Internet of Things. So it will be just an introductory session where we will be knowing the basic things. So first coming to the fact what is mean by Internet of Things. So as we know, the Internet of Things is connecting many devices to the internet. So we'll be having different types of components and we will be connecting those components to the internet. So that is basically the Internet of Things. So coming to the definition of Internet of Things, so it has got some particular definition, so which says a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols where physical and virtual things have identities. A physical attributes and virtual personalities and use intelligent interfaces and are seamlessly integrated into the information network. So often communicate data associated with users and their environments. So the fonts which I have colored in different, that is in maybe blue or green or some orange. So these are the important words which tell about what is meant by Internet of Things. So a dynamic global network infrastructure, so that is here a dynamic. The meaning of dynamic here is that the Internet of Things means the end nodes of this IoT environment will be changing, so it will be not like a fixed type of nodes will be present. So the nodes are changing as the system evolves here. And the meaning of here self-configuring. So self-configuring means the nodes should be able to adjust with each other. So in ad hoc type of communication where the nodes will be deployed suddenly. So for example, if I take the forest monitoring sensor, so they will be deployed from the chopper. So they will be randomly thrown into the forest, so they has to adjust the position of each other with respect to the distance between the nodes. So if a node is present over here, then from this node, let us say 100 meters away the other node should be present, so it will be programmed in those nodes and they will follow the same here. So until the distance between them will be 100 meters, they will be moving away from each other. So these are the two nodes. So ad hoc means we are not deploying them physically, we are just putting them in a random manner and they are capable of configuring themselves. Okay, so that is meant by self configuring. And then interoperable communication protocol, so they should be able to talk with each other. So this node should be able to talk with this one, and if let us say there is other node, then it should be able to talk with the other neighbor node here. So node 1, let us say this one is 1 and this one is 2 and this is the third one. Okay, so this is third one. They should be able to talk with each other. So that is mean by interoperable communication protocol. So they have got particular protocols here, so with the help of that one they will be communicating with each other. Okay, so that is the meaning of interoperable communication. And then where the physical and virtual things have identities. So the physical things are the nodes. So this is one node and this is the other node and this is the third node. So all these things have got particular identities. So they will be having their MAC address and IP address. So MAC address is called as physical address and the IP address is called as virtual address as it is assigned by the server. So they are having both MAC as well as the IP addresses here. So seamlessly integrated, the meaning of this one here, seamlessly integrated means they should be bound with each other, so there is no separate things like it is independent of the other one, so they are all together, so they are acting as a team here, and often communicate data associated with users and the environment. So they will be transferring the data between user and the environment, so they are sensing the environment here, then we will be having a server here, let us say yes, and then they will be transferring the data to the server, then we are the end user, so we will be having a mobile phone or a tablet, then we will be using the data here, so let me just label it D. So here the environment is present, so let us say this is the environment, and they are sensing the temperature here, and they will be sending it to the server, and then server will be forwarding the same data to the user here. So this is how the Internet of Things works, and this is the basic meaning of Internet of Things, where every node is connected to the every other node in the environment. And the next capability of IoT is a reduced cost. So here it is reduced cost. So due to the components are cheaper, so they are using the newest technologies. So the cost of the devices will be less as compared to the conventional cost. So the devices in IoT will be functioning multiple tasks at a time. So they will be, let us say, the temperature sensor, that is DHT11 is a sensor which is used for both temperature and humidity monitoring. So if you use LM35 sensor, so it will be only monitoring the temperature. So it is basically the temperature sensor, but you need an extra sensor, so which is required to sense the pressure. So but if you use the DHT11 sensor, we will be measuring temperature as well as the pressure at a time, so there we will be cutting our cost. So for instead of two sensors, we will be having only one sensor here. So like this, some of the major technologies which will be used in the IoT cause the cost of the overall network to be less. And the creative innovative services, so of course we will be getting the creative and innovative services from the IoT, so like smart home, smart agriculture, and the supply chain monitoring, then inventory monitoring. So what are all the things which are there in our inventory, so what we need to order, so in order to make the supply smoother, so we will be having a good service by the IoT in case of inventory model. And many more ideas are there, so depending on the user we can implement a lot of things there. And then new revenue stream, so this is also very important point here. So the IoT opens the door for number of jobs here, so lakhs of jobs are open for newcomers there, so either it may be for program developers, then the embedded system designers, so all other uh, type of jobs will be present due to the IoT environment. Then let us move on and discuss characteristics of IoT. So what are all the characteristics or the features which should be having in case of the Internet of Things network? So first one we can define dynamic and self-adapting. So dynamic, as I have said, dynamic, the meaning of dynamic itself is changing, and self-adapting is they should be configure themselves. So as I've said, if we drop some nodes in a ad hoc manner or in a random manner, then they should maintain a equal distance from each other. So like this, they should form a particular shape in order to maintain a equal distance of, let us say, 10 meters here. So they should be away from each other by a distance of 10 meter. So everything should be 10 meter from each other. So this is the meaning of self-adapting. Dynamically adapt with changing context and take a action based on operating conditions, user context or sensed environment. So example for this one is the surveillance system, so where depending on the actions of a target we will be taking the particular operation. So That is mean by dynamically changing. So we can't say the environment will be fixed, it may change. So that's why the IoT or Internet of Things system should be able to catch up with the changing environment. Then self-configuring. So self-configuring contains 2 points here: setup networking, then upgrade software with minimal user intervention. So the meaning of setup networking is the same here. So as I've said, the environments will be, the nodes will be dropped randomly, they should configure themselves. And upgrade software with minimal user intervention means they should be able to upgrade themselves, so without going and touching each and every node by a human and upgrading the software into them. So as you can see, our computers will be getting a software update every now and there. So it is basically the example for automatic upgradation, where at a time all the computers in a batch will be getting a software update. So there is no such thing like the executive from our computer or a lab in will be coming and connecting the device or physically connecting with this the laptop, and he will be upgrading the software. It's not like that. So at a time upgradation will be sent to all the computers and they will be upgraded. So that is mean by the minimum intervention of the humans. So that should be the characteristics of this IoT. Then interoperable communication protocol. So as I've said, the communication of the nodes themselves is very important. So they should be able to communicate this one and this one. So heterogeneous devices working together. So it may be a sensor, it may be a actuator, it may be a server here. So they are not the same family of devices. So it is sensor, it is actuator, and it is a server. But with the help of the protocols which will be sitting in between them, that is virtually, they should be able to communicate with each other. So that is the meaning here. So they should be able to operate with each other with the help of the protocols there. Then unique identity. So each and every node in the IoT environment should have a unique ID. So it may be a MAC address or a IP address. So monitor status. So why should have a unique ID? So to monitor the status of the device and query the device, so ask something to the device and control remotely. So if it is an actuator, then to do some work with the help of actuator, we should be able to send some command to the actuator. So to send the command, we should have the identity. So it is just like if you want to call someone, then we should know his or her name in order to call him or call her. So in the same way, we should have the address of this node in order to give some command or receive some data. So to do anything with the node, we should have the address. Okay, then integrated into information network. So this is the last point which says the IoT environment should be integrated into information network. So to communicate and exchange the data with other devices and systems. So this is basically needed because we have to exchange the data between different types of devices here. So they should be integrated with each other. So in a web, they should be all integrated. So this is the family of internet where all devices will be present and they are all connected with the help of this one thing, that is internet here. And data analysis and prediction. So this is the end result which we will be expecting. So if you are monitoring something or monitoring a supply chain, then we will be getting some data. So some graphs we will be getting. Let us say the time versus the consumption of the goods. So let us say consumption on the y-axis. So we'll be getting a graph which shows at this particular time the consumption is at a peak. So we can get some result with the help of IoT graphs. Okay. So now let us move to the Internet of Things evaluation. So how the evolution of IoT happened. So first we will be having one thing, that is the pre-internet. So the internet era. So before that one, what we will be having is called as pre-internet. So where the communication happens between human to human. So there is no such thing like radio waves at that time. So At that time only the human to human communication is happening, so we'll be using only the fixed and mobile telephony, and SMSs will be sharing. So at that time there is no such thing like the human is able to interact with the machine. So at that time only telephones are there, so I will be speaking in one phone and my friend will be speaking in the other phone, so we are just basically having a conversation between us itself. And in the next step, so this plus indicates the next step here. So here the added things are smart networks. So smart networks means we will be having the websites at that time, so internet of content. So we will be storing the content in the internet and we will be accessing with the help of www. So the www means world wide web. So we will be storing the data in a data center and we will be accessing from the world, any point of the world. So that's why it is called world wide web. So if you are at any corner of the world, you will be able to access the data remotely. So the example for those things are email, then information, that is just basically the Google, then environment, Facebook. So entertainment I can say. Then next added thing is the smart IT platforms and services. So here comes the era of IT. So here the internet of services. So services are being given through the internet here. So web development 2.0 you can say. So the main two things which are added in this era are the e-productivity and e-commerce. So we will be exporting some software in the e-productivity. So the company which is best known for its softwares is the Infosys and the TCS, which is an Indian company. Of course the Infosys is also an Indian company as well. So there are a lot of companies which are exporting the software in India. So about a 40% of world software is being exported from the India itself. So basically the Bangalore, that is called as the Silicon Valley of India. And the e-commerce companies, that is Amazon, Flipkart, eBay and Alibaba. So those are the best examples for the e-commerce. So recently the Jio has also started the e-commerce. And the next evolution is the internet of people. So the peoples are getting connected with each other. So as I said earlier also, the only meaning of IoT is connecting everything with the every other thing. So here in case of internet of people, every people is get connected with the every other people. So every individual is connecting with the every other individual here. So the best examples for connection of peoples is the social media. Of course we will be spending a lot of time in social media, so that's good, we should spend. So WhatsApp, Instagram, Facebook, WeChat, I can list a number of social media apps here. So it may be a Skype, Facebook, YouTube. So these are all social media apps. Okay, so in the next evolution, the Internet of Things comes, that is the final year. So in Internet of Things, what will be happening is the machine to machine communication is very important here. So that is the key point which we can figure out here. So a machine to machine communication will be happening in case of Internet of Things. So a sensor will be talking with the other sensor, a sensor will be talking with the actuator, a sensor will be talking with the server. So as you can see here, a sensor is also machine and a server is also having the machine. So two machines are talking with each other, so that is called as machine to machine communication. And here the things are identification, tracking, monitoring, then automation, actuation and payment. So all are included in case of Internet of Things. So everything is included here. Okay, now let us move to the next topic, so that is applications of IoT. So as I earlier also I shown you how the applicable areas are evolving in case of IoT. So we will just list out some of the application areas. So people connecting with things. So this is the first thing we can figure out, that is people connecting with things. So here is the human body, so which you can see here. Okay, so this human body has got a sensor, that is a ECG sensor here, and also has got a motion sensor to monitor the motion of this human body. Then a motion sensor is connected to the hand, legs, all those things. So just basically to count or number of steps. So some mobiles in nowadays are having the apps which will count the number of footsteps which will be walking in a day. And ECG sensor, it will be monitoring our heart rate. Then that will be sent to the mobile device, and which will be obviously connected to the internet, so which is shared with the your personal doctor at the hospital. Then it will be stored in a your computer, so that you can analyze the data again, or it can be sent to a broker here, so that it will be forwarded to the other person, so it may be your loved one. Okay, so like this the people will be connecting with the things. So here the connection between people and the things will occur. And then the next thing which we can figure out is the smart home. So what is meant by smart home? A home which is capable of configuring itself. So it should be, we should be able to access the home from remotely. So there is no need to go and physically touch all the things in the home. So we can uh, handle the things which are present in our home remotely, that is with the help of our tablet or a mobile phone. So we are having lights, speakers, window shades, and laptop, TV, tablets. So those are all operated with the help of one device, that is our IoT device, that is phone we can say. Then thermostat which will be maintaining the temperature, then smoke alarm in case a fire is set in our home, then irrigation systems to garden our to give a water to our garden, then lights, refrigerator. So what should be the temperature inside the refrigerator, we can maintain that temperature with the help of this mobile. Then lights in the kitchen, whether we want to be off or on, we can monitor with the help of mobile. Then video surveillance, that is CCTVs, we can monitor. Then door locks, so this is very important. So door locks can be maintained with the help of mobile itself. Then the speakers, TV, Wi-Fi router, then a garage door. So this is also an important thing. We can open the garage door or close at any time with the help of an IoT device remotely. Okay, so the next application is the smart egg tray. So basically the meaning of smart egg tray is the egg tray will be able to tell us how many eggs are remaining in the tray, and at what time they are going to be spoiled. So before that we should eat them. So they will be having some sensors over there, and they will be monitoring the health of each and every egg. So this is very pretty idea I can say. So next thing which I can figure out is the smart washing machine. So smart washing machine basically gives the remote access for the washing machine. So we can load, once you load the clothes into the washing machine, you can change the temperature, or we can change the time of that washing. So that's it, smart washing machine. And smart lighting, so as I said earlier, smart lighting means we will be able to operate our bulbs remotely. So with the help of mobile itself we will be switching on or off our bulbs, so that is smart light. Then smart AC, we will be maintaining the temperature of our room with the help of our mobile itself. Then smart garbage cans, so this is quite interesting I can say. So many times we can see in our India the problem is that where the garbage collectors are not coming at a time. So many times we see that the garbage from the garbage cans will be coming out. So until and unless the garbage comes onto the road, we Indian people are not lifting the garbage. So that should not be the case. So the garbage collector should be able to tell us we are full, so empty us. So this is basically a smart garbage which tells to the server or the headquarter that the garbage within me is full, so you need to empty it, so that it will be not going on to the roads. So that is basically a pretty idea. So it is implemented by Big Belly. Then the smart slow cooker. So basically it is also a home appliance there. So the cooker will be having some sensors, and we are able to maintain the temperature and pressure inside that cooker depending on our type of the use so application. Then coming to the physical design of IoT. So what are all the physical aspects which are present in the Internet of Things network? So the things in IoT usually refers to the IoT devices which have unique identities, so and can perform remote sensing, actuating and monitoring. So what are all the expected features from the IoT environment? So they should be able to access from the anywhere from the globe, that is remote sensing, then actuating. So we need to do some work, then we should be able to send some commands as well. Then monitoring, we will be just seeing all the environment, or so surveillance cameras are the best examples for monitoring capabilities. Then what are all the features or the functions which can be done with the help of IoT device? So they can include exchange data with other connected device and applications, so directly or indirectly. So it should be able to exchange the data with the other connected devices. So direct connection here, directly and indirectly, meaning is that, so let us say there are two nodes, let us take three. So a direct exchange of data means this node is able to communicate with this node, so they are able to communicate directly with each other, and they are transferring the data with themselves. Okay, so but the problem is the first node here want to transmit the data with the second node, but there is no direct path between these things or these nodes. So at that time what we'll be doing is, this first node will send the data to the intermediate node, and this node is able to forward the data to the second node. So like this, if there is no direct path between these two nodes, it is able to communicate with the end node with the help of an intermediate node. So that is the meaning of indirect exchange of data. So it is first transferred to the intermediate node, and then it is transferred to the end node. So that is basically with the help of intermediate node we will be transferring the data. So that's why we will be calling it as indirect exchange of data. Then collect data from other devices and process the data locally, or send the data to centralized servers or cloud based application backends for processing the data. So we should be able to process the data locally, or we should send to the centralized device, or we should send it to the server. So if the data generated is very small, then we will be having, so if there are number of sensors, so let us say this is the group of sensors, and if the amount of data generated by these sensors is less, then it will be sent to the centralized device. See here, so this is the centralized device to which all the data will be sent from these different nodes, and this will be processed and directly sent to the mobile phone or the end user. But the data, if the data generated by these end nodes is very large, and if the centralized device is not able to handle that one, then it will be sending it to the server here, and this server will be having powerful machines. Then it will be processing the data in there, and then it will be sending to the user. So the e-commerce companies are using this type of communication model, because they will be having n number of customers, and it will be not easy to handle that data with the help of centralized device. So they will be sending it to the server or to the cloud. So cloud is basically the data center itself, and in that cloud the data will be processed, and the end results will be sent to the user here. And this type of localized processing of data is done where very small amount of data are produced. So I can say, if I am monitoring some garden, then I can have a centralized device, and it will be connected to the tablet or the computer in my house. Then it can send the data directly to my house, so which is not sent to the server, it will be just forwarded to my desktop here. So that is basically the example for centralized device processing. And the next point says that perform some task locally and other tasks within the IoT infrastructure based on the temporal and space constraints. So as I said, this is giving the same meaning here. Then what will be the possible general block diagram for an IoT device? So coming to the block diagram of an IoT device, so it consists of lot of things. The connectivity, which is with the help of either USB host or the Ethernet, that is RJ45, I can say the standard name for that one. Ethernet means all devices will be connected with the help of an physical cable. So USB host means a physical cable itself. Then we'll be having a processor for processing the data, then audio video interfaces, so to get the audio and video information. So it may be an HDMI port or 3.5 mm audio jack, which is basically a round pin, which is basically a earphone, we can say. Then a RCO device for an video. Then input output interfaces, so for sensors and actuators we will be having many input output devices. So it may be a sensor or a actuator. So sensor is basically input device and actuator is the end device, which is the output device here. So they are connected with the help of UART and SPI, I2C, CAN. So these are the communication protocols which are used by the server or centralized device and the end nodes here. Then storage interfaces will be having either it may be a SD card storage or the memory of the system itself or other things. Then graphics, so we'll be having a graphical user interface GPU, so in order to have good graphics. Then memory interface, so we are having DDR1, DDR2 or DDR3 type of ports there. So these are all the components which will be together connected in order to have a IoT network. So an IoT device may consist of several interfaces for connections to other devices, both wired and wireless. So they may be wired or wireless, we can depending on the application and type of network which we want to implement. So input output interfaces for sensors, then interfaces for internet connectivity, then memory and storage interfaces, then audio video interfaces will be having. So this is the general block diagram or a very basic type of representation for an IoT network, I can say. Then this is a very pretty slide, I can say. So here we'll be having IoT protocol. So in the beginning itself I have said IoT is using some special type of protocols which are lightweight and they are consuming a low power as compared to the conventional type of protocols, that is HTTP. So what are all the protocols which are used in the IoT? So we are having different types of layers here. As we know, these are all the layers which are used by any type of communication model. So application layer, transport layer, network layer, and the link layer, that is basically called as data link layer also. So the application layer, the protocols which are used in application layer are the HTTP, that is hypertext transfer protocol, then CoAP, then WebSockets, then MQTT, that is message queuing telemetry transport system, then XMPP, then DDS, then AMQP. So out of these, the ones which are used very popularly are the MQTT and CoAP. So these are used very popularly. The MQTT is having only 2 bytes of header, so which is very less as compared to the HTTP, which is having a very big header. So as the length of the header increases, the load on the end devices for processing that message will increase. So eventually the amount of power consumed by the end nodes will be increasing. So the length of the header is directly proportional to the amount of power consumed. So it is also affecting the capabilities of the end device. So if the end device is not capable of processing that one, then a error will be happening at that time. And the transport layer consists of two things, the TCP and UDP. So the internet and other things are using TCP mainly, so the MQTT uses UDP here and CoAP uses TCP or UDP, so it can use both here. So these are the layers which are present, or the protocols which are present in transport layer, I can say. Then network layer consists of three things, the IP version 4 networking or IP version 6 networking or the 6LoWPAN type of networking. So these two are the protocols which are used for the internet, and this one is used for the IoT here. So 6LoWPAN is the modification of IP version 6, I can say, which is supporting n number of devices with the small overhead and low processing overheads for the end devices. So basically here the meaning of 6LoWPAN is 6 means it is derived from the IP version 6, and low pan, so low means it is using very low power, and pan means it is used for the personal area networks here. So the IoT sensors will be forming the personal area networks, that is they will be having a small groups here. So I can say this is the one personal area network. So to connect these nodes inside this personal area network, the 6LoWPAN protocol is used. So you have got the idea why I am saying 6LoWPAN. 6 is from IP version 6, low is for low power, and then PAN means it is connecting the personal area networks. So that is basically used very enormously in the IoT type of environments. Then the last one, that is the data link layer, so which uses 802.3, that is either the Ethernet or WiMAX 802.16, then 2G 3G or LTE type of protocols, or 802.11, that is Wi-Fi, which we will be using in our day-to-day life. Then 802.15.4, that is low power wireless personal area network, I can say. So this is also called as Zigbee type of communication, which will be handling n number of nodes which are meshed with each other. So it is able to handle a lot of complexity. So these are all the protocols which are used in link layer. So this is listed just here. So link layer consists of this Ethernet, Wi-Fi, WiMAX, and network layer consists of IP version 4, IP version 6, and 6LoWPAN. So basically it is at a frequency of 2.4 gigahertz, it is saying. So a moderate data rate of 250 kilobytes per second. So this is enough for the sensors to send the sensed data, because we are not sending any high amount of data in case of IoT. So we will be just sending the let us say door. If you are sensing a door, then we will be sending the data which is related to the position of the door. So either it is closed or open, or it is a half open. So we will be sending some let us say we will be assigning 1 for the closed position and 0 for the open position, and we will be sending some other value, let us take 2 for the in between position, that is it is half opened, or we can say half closed. So we will be having only small data there, so we are okay with the small data rates here. And then transport layer consists of TCP and UDP. Okay, so application layer consists of these things as I have explained already. So this is all about basics of IoT. So what is mean by IoT, what are all the protocols in IoT, features of IoT, and then the expected applications for the IoT. So I hope you like this video. Please guys, if you are new to the channel, hit the like button, and if you are not subscribed to the channel, please guys subscribe the channel. Thank you, thanks for watching.